Welcome to this week's narrated PowerPoint presentation. This one's going to be about the restoration of a French electric master clock. These were beautifully made in the mid-1800s to late 1800s and were used as a time distributor system for slave clocks that were located throughout an office building or a railway station or a hotel, wherever there was to be synchronized display of the time throughout the building. Here's the clock as it was presented at a local auction house here in Sydney in September 2017. It was by Victor RECLUS of Paris, and he was a very well-renowned clockmaker in the same category as Garnier, who also made electric clocks. And they did collaborate because there are certain device inventions of RECLUS on both Garnier and RECLUS clocks. Here you can see the base has been covered with plaster and textured, something like a gesso. They've plastered over switches, they've plastered over the terminal blocks at the back and painted it brown. You can also see that the original wiring, which is cloth covered, has been stretched and distorted. There's an incorrect pendulum fitted as well, probably just to sell it, and a beautiful glass dome, which does actually fit this base, would appear to be original and would be irreplaceable. So this is the way it was when purchased. No guarantees and no warranties. Here is the beautiful enamel dial in perfect condition with the original Breguet style hands fitted. But when you look at the back, it's a mess of wires, cams, contacts, terminals, bits of wire hanging off in various places, all a bit of a mystery as yet. But nevertheless, we will work our way through it. It soon became obvious that this was just not a timepiece with a single output to a slave clock. This was a very complicated master clock. There were double pole switches for 30-second intervals on the front plate, alarm contacts for 15-minute intervals on the front plate, slave movement contacts with 60-second intervals on the back plate, extra contacts for 60-second intervals at the bottom of the movement, remote strike contacts at the back of the hammer. And even then, when I started to study it further, I found more of these contact systems. On the base, in front of the clock, was a push button, inoperative because of the plaster and the brown paint. But it's actually a push button to advance the slave clock, should it be lagging behind the master. To understand more about how this clock worked, the first stage was to clean it up. I wanted to get rid of all this plaster and rubbish that had been coated onto the base, and I did find underneath the original black paint associated typically with French clocks. I recoiled the wires so that they were no longer stretched and strayed, cleaned the plaster away from the brass terminal blocks on the back, and ultimately got the base back to its original. And in the top left picture there, you can see the ivory push button sticking up through its little cup. Step by step, I removed parts, cleaned off old verdigris, dirt, old oil, and put the parts back again so that I would be able to evaluate what was there and what was not there. First thing I could see was there was no power source. This clock had no mainsprings. What drives this clock? There was a big hole in the back, so something major was missing. So having cleaned everything and reassembled the clock, I found a nice mercury pendulum for it of the correct length, braid to protect the base and the glass dome, and then I had a clock that was looking great but would not run because there was obviously some parts missing. I soon found out what was missing. Searching on the internet through an electric clock website in the Netherlands, I found a clock pictured here on the left with the parts that I was missing. You can see with my clock on the right, everything that's missing is behind the gong. The most obvious thing that's missing is an electric solenoid, a coil of wire wound around a wooden bobbin with an iron core through the centre and two posts, one at each end. The iron core carries the magnetic flux to the ends, then it carries down the posts ready to be utilised in pulling the armature up when the electromagnet is activated. The fit of these posts to the core has to be so good as to be almost no gap at all. Any gap and the magnetic flux is reduced. Below the armature is a large leaf spring, and this leaf spring is actually the power source that runs the clock. It looks rather complicated, but the operation is fairly straightforward. When the green coil is activated, the magnetism at the poles pulls the armature up onto the poles, and the vertical lever at the right end of the armature has a hook at the top, and it jumps up one tooth on the wheel, and then the large leaf spring below the armature applies downward force and drives that wheel, thus activating the time mechanism. After considerable trial and error, I completed the construction of all the missing parts, making sure that everything operated correctly and at the right time. Once that was done, I was then able to strip the entire clock down and clean all of the parts to give me a complete restoration for the movement. As I mentioned right at the beginning, this wasn't a simple clock to operate one slave. It had many circuits for operating different alarms, clocks, and activities. It took me a long time to work out where all the circuits were and what all the terminals on the back were for, and ultimately I found that there were at least 5 circuits that I could reconstruct. There was the clock circuit, a slave clock circuit, a 15-minute alarm circuit, the push button slave clock adjustment circuit, and a remote bell strike circuit. Very complex, but once sorted, rewiring was undertaken and completed. Here's the completed restoration. You will note that I've not done anything to the brassware. This was coated with a golden lacquer in its original condition, typical of scientific instruments of that period, 1875. It was in such good condition, it was not appropriate to remove it. I know from the picture of an original clock shown on the title page that this clock would have originally been supplied with a temperature compensating mercury pendulum. But concurrent with the mercury pendulum, Ellicott produced his bimetallic compensating pendulum, and I liked the look of it on my clock. I just happen to have one of those Ellicott temperature compensating pendulums of the right size, and I can see in this picture here the beauty of both, but I do like the Ellicott because it reflects the dial with a white porcelain centre and a brass surround. Every master clock needs to do something. It must have a slave clock attached. RECLUS actually made slave clocks to go with his time distribution system, but they are quite rare, even rarer than the master clock. But eventually I tracked down a slave clock movement by RECLUS and purchased it, as you can see, in a very, very sad condition, but nevertheless restorable. Underneath all of that dirt, grime, corrosion, verdigris was a beautiful slave movement. With a little bit of work on the coil to get all the wiring back into position, cleaning up of the ironwork and the brass work, produced a very, very nice slave movement. Here is the movement fitted into a solid timber case with an original porcelain enamel dial and some beautiful trident hands, all consistent with RECLUS slave clocks. The terminals at the top are for the wires to come from the master clock to bring the pulse over every 30 seconds and advance the hands on the slave to match the master clock. One of the features on this clock was the ability to strike remotely. In this picture you can see the hammer rod extending off to the left with the head beyond the picture. But on the right hand side you can see 3 contacts. When the hammer head is raised, those contacts come down and touch onto the silver contacts at the bottom right of the picture, thus closing another circuit. And that circuit then can be wired to send the strike signal to a remote bell. As this clock is now domestic rather than industrial, it's not quite right for it to activate a remote bell or a horn. So I decided to have a bit of fun and design and construct an automata that would be driven by the signal from the bell. In stock, I had this beautiful little bell, a true bell, always waiting for some project where it could be used, and this was really appropriate for what I wanted. You can see here now, to construct the person to strike the bell, I've made a spine out of 2 brass rods and then pivoted 2 arms at the top with a lever to lift and drop the hammerhead onto the bell. I purchased a small solenoid from J-Car, and then around the spine started the construction of a brass wire body space frame, soldering small pieces of brass into the shape of the body that would cover the actuation system within the body. Using old recycled oak, I built a base and a gantry for the bell, and then positioned my solenoid and figurine such that everything would be suitable for the strike of the bell. Over the space frame, I then started to apply cloth glued into position with a white glue, gradually building up a complete body, but allowing for the arms to raise and lower. Here you can see the skin has been completed and coated with white glue to make it stiff and firm. I then built up the head, hands and feet with plaster of Paris, crudely at first, to give me something to work with in the next step. I sculpted the head to give me the basis for what I had in my mind all along for this little guy. He'll be revealed shortly. There he is, painted and clothed as a friar, warden of the bell, responsible for awakening all of the monks in the monastery, ready for their prayers. I've constructed a plinth around the base at foot height, ready to enclose the solenoid and make it disappear. Here he is now, apparently standing on a plank deck, ready to start ringing the bell. A little bit of staining and varnishing to be done on deck, but basically complete. Move your cursor around the picture there and an arrowhead will pop up and you can watch the friar strike his bell. Here they are all grouped together. The master clock in the centre, slave clock to the left and the remote striking friar on the right. Thanks for watching another of my presentations. I hope this one was of interest. It's certainly different. If you have any questions or comments that you'd like to make, you can send them to me on an email as shown at the bottom of this page. If you'd like to have a look at some of my other projects, you can go to my website at fixaclock.net. Thanks again. Stay safe in what appears to be an extension of our lockdown period. Thank you and goodbye.